Our lesson today is Chapter 5, Lesson 6, Graphing Inequalities. So right here I've got an equation. Here I've got a similar looking thing, but it has an alligator mouth, so this is an inequality. Equal sign, not an equal sign. Let's go think back to an earlier chapter. How do we graph something that looks like this? Well, I could make a table of values, and I could pick 0, 1, and -1. Or I could use the 5 that's in the back. That gets me my first dot on the y-axis. That's my y-intercept. And then I use my 4 as my slope. That means up 4, right 1. If I go 1, 2, 3, 4, and 1, I draw another dot. And then I do it again. 1, 2, 3, 4, 1, draw another dot. Connect the dots, put arrows on it. So my answer is purple. Anything purple is the answer. So this line that goes on forever and ever and ever, this dot is an answer, but so is all the purple that's in between. There just happen to be decimal numbers. This has whole number answer, but all of this is purple. Forever and ever and ever, the purple is the answer. Okay, now let's graph this inequality. I could still make a table, pick 0, 1, and -1, or I could still use the y-intercept and the slope. I still get the same 3 dots. But the alligator mouth does not have a line under it, which makes the line, I'm not going to do a solid line, I'm going to do a dashed line. Like that. It goes like it's dashed. So then I have to look at this and say y is less than this line. So it might be the section up here, or it might be this section right here. The more that you do this, the more you're going to just know which section it is. Less than, does the less than feel like maybe your gut's talking to you? Does this feel less than our line? Does this feel less than our line? Let's stop and do a question. This is a total guess. Would you guess that less than is the green section, or would you guess the less than is the pink section? Well, you know now the correct answer is pink. The pink section is less than. But how am I going to know if it's pink or green? Well, I need to pick a dot in the pink section and I pick a dot in the green section. So I think I'll pick this dot, and I think I'll pick, let's pick 0, 0. 0, 0 is a good one. So I'm going to pick each of those dots and see which one is true. And like I said, the more you do this, you're going to just know. But in the beginning, you should pick some test dots. So pink's ordered pair is 3, -2. That's the ordered pair for this dot. Remember that 3 is the x number, and -2 is the y number. So I'm going to substitute 3 in for x. I'm going to substitute -2 in over here for y. And I'm going to see if the sentence is true or not. Okay, so I wrote this equation, but I wrote it with my 3 and my -2. Here's my y, here's my x. It already had a 4, so I multiplied by 4. It already had a -5, so I multiplied by -5, or put a -5 at the back. So now, is -2 less than 12 minus 5? Is -2 less than less than 7? Sorry, not -7. Is -2 less than 7? The answer is yes. So I'm going to color this part of the graph in. Again, everything purple is the answer. So everything that you see purple. The dashed line is part of the answer, and every dot that would be in this section forever and ever and ever is an answer to this inequality. Anything in this white section that I didn't color, used to be green, that section is not an answer. Let's go back and check. We had equal sign, only a line. Inequality, a kind of a line, it was a dashed line, and there was shading. We shaded part of the graph. So there's a whole bunch of answers to this. There's only one line that's an answer to that. All right, think back to these inequalities. One has a line, one does not. What's the difference? Well, without the line, it's an open dot. With the line, it's a closed dot. They're both shaded to the right, but the line says it also includes the two. So what does that mean when we get to these lines? This alligator mouth doesn't have a line, but this alligator mouth does have a line. What does that mean for this picture? So I would have rough sketch. I would start at 4, and I would have a positive slope of up 1 over 1. I would have a positive slope starting at 4, and I would go up 1 over 1. Very rough sketch. So if I don't have a line, then this is dashed. If it does have a line, it does include it, it's solid. So we call this one a dashed line, and we call this one a solid line. So it's similar to open dot and closed dot. Does not include 2, but shades everything to the right. Does include 2, shades everything to the right. Right here, dotted line, and we're going to still have some shading. This is our shading. And solid line, this is our shading. So dashed line and solid line. All right, we're ready for our next question. Will this picture have a solid line, or will this picture have a dashed line? So the answer is that it will have a solid line. This line under the alligator mouth makes it also include all the numbers on the line. All right, so I'm going to use my intercept, which is nothing. So I have a dot at 0. I'm going to use my slope, which is negative 2/3, to go down to right 3. But I don't have any more space, so I'm going to have to go up to left 3. We just said solid line, so I'm going to connect it. And now I need to decide, do I shade up here or do I shade down here? Well, less than, the way I just said it, almost should have given that away. Do I shade up here or down here? If it's less than, my gut is saying down here. But we need to pick a point. We need to pick a point in the place where we think it is. Any point will do. So like right here would be a good dot. Here would be a good dot. Here would be a good one. We don't want to pick something that's on the line. We want to pick something that's down in the section we think is the answer. So let's pick this dot right here. And that dot is -1, -3. So I'm going to replace x with -1 and y with -3. Here's time for a new question. What will it look like when I replace x with -1 and y with -3? Well, if I replace y with -3, it's going to go there. If I replace x with -1, it's going to go right there. So I'm asking myself, is -3 less than the answer to this? Well, 2 negatives make a positive, so it's positive 2/3. Is -3 less than or equal to positive 2/3? The answer is yes. So we were correct. We're shading down here. And you can shade with your pencil, with a color, just get close. Just go scribble, scribble, scribble. All right, your final question is, if you have a question in the book that looks like this, which method are you going to use to get your dots? Are you going to scribble and solve? That would be one option. Remember, that's where you scribble this guy out, you solve it, scribble this guy out and solve it. So you'd have 2 dots. You're still going to have to shade. It would be a dashed line. But how are you going to get the line to begin with? Are you going to make a table and pick 3 X's and figure out your Y's? Or are you going to rearrange so that it looks like the questions we've been doing? Rearranging means I'm going to take 5x and move it to the other side, subtract 5x, make it a negative 5x, and then use the slope and intercept. There's not a wrong answer, but I'm curious, when you see this question, which option do you like to use to graph it?